module BTR 2160. Principal contents of the lesson is the post-processing menu. I repeat, some functions we are used in the introduction. I have my file explorer open. I take the sim file. In the graphics window I have now my part. What's missing are the two files that I have to fastest way to reload. So I have all my files. I make some changement. I make the beam shorter and I will change the direction of the force. For shorting the beam, I click on the model, then the application modeling. In the application modeling, I go to the sketch. I shorten my part to 300 millimeters. So that's my new part. Then I return to the application pre-post. I'm going to the FEM file. I see there are some changes made. I have to make an update. As you see, I have now the new mesh. I change to sim. I click either on the force graphically or I take it here and I change the direction of the force in X direction, so I have a beam under traction. I have to redo the solution process. There should be no problem, though I don't control what's happening. I go to the results and I see what's happening. For a fast understanding, I see, if I have traction on this beam, there is a changing of the geometry here. But take note, the large displacements are taking place here and they are 300th of a millimeter, so it's quite small. So this deformation is also really small. I stop this animation and I show you in the post viewer how I can change the deformation size. Here I have the percentage of model. That means 10% is the deformation, 10% of the model. So this model is 300 millimeters long, though the deformation will be just 10% of 300 millimeters, so it's 300 millimeter moving. I can enlarge it. I can say, as an example, I go up to 50%, and you see what's happening on the screen. For the computer scientist, it's no problem to make this graphic. For an understanding as an engineer, it's quite bizarre, but it's just the linear model in a scale. So if you have a result, I propose to you to put it on absolute and the scale of 1:1. So if I have that, I make the animation. You see this small deformation on the screen. It's not anymore visible, it's only in the colors visible. So that's the first thing we made. We can find this entrance here, deformation, or a shortcut will be this icon, and here I have once more the possibility to go back to 10% of deformation. It gives an understanding of the deformation, but take care it's not the real deformation you see. Now, beside the displacement, the stress is something interesting. Have you seen, if I take stress elemental, I have not the same kind of picture. So all the time just go on element nodal stress elemental. Every element has the same stress levels, the same color. It gives us an idea where the elements are on a good size, or here especially a bad size, and the good size here, changing of colors is not so large. That I will see in the next lesson we do next week. So normally take stress element nodal, and you see here the stresses. I can go once more in this post-processor menu, and I can say the display should be on the feature, though I see not anymore the elements, only the colors, but you see in the colors it's still visible this problem of the elements, that the elements are giving the sizes of the stress, and it depends from where I read the stress, so not so easy in the moment. We leave it on that. You know now how to make active the finite elements and deactivate visibility of finite elements. As the next thing, I look on the reaction forces. It's better just to take the reaction forces in the x direction, and as you see there are some strange colors here because the results are just on the nodes. If I go and ask identify results and I change to feature face, I see the reaction forces, the sum of that is just quite near from our 10,000 Newton I was pulling this face. So that's quite a good control. Just control the reaction forces. I close that. I show you that two menus are for nothing. That's the nodal menu, and that's the reaction moment menu. You remember in the theory I said you in the tetrahedrical, or in general in 3D elements, there are no rotations, only the displacements. Okay, I go back to stress element nodal. I introduce you like yesterday the legend. Here you see specified. I go down and say here the specified, I have it from 0 up to just limited to 24 megapascal, and you have this not so bad picture. You just leave it on this level. What you learned until now is in this post viewer menu you have seen displaying the elements or not, deformation, the scale, and to put an own legend. So the extremes here are given. In the moment we are just living with this von Mises stress. I will come on this just after the holidays. We will look at these stresses there. In the moment we are just making finite element analysis, and they are happy to see a fun Mises stress. So that's all in this lesson. I go back. If I want the state saved, think about it, save all. So that's okay for today. For this lesson. The next lesson will be on meshing menu.